Good evening. How are we all? We are all good, thank you, Delta. And it's a special day today, because today is mine and Claire's wedding anniversary. And yes, I am streaming on our anniversary. I will probably be beaten for that, but wouldn't want to disappoint everyone. So I dedicate this stream to Claire, without whom none of this would be possible. Thank you, Festus. Yeah, I did buy Chinese, so I mean that counts, doesn't it? And I helped her get the Christmas shopping today as well. Thanks, CSI. So, tonight, I fancied doing something a bit different. I was actually watching one of Obsidian Ant's videos about the scale of space and the challenge of filling that scale with content and having that content be meaningful. One of the criticisms that's levied against many space games, especially ones that have massive scale, is this whole analogy of being an ocean wide and like puddle deep, and that's definitely something we're going to struggle with unless we come up with solutions to this. So one of the things I want to do is have dynamic object spawning within a star system. So the way the galaxy works is obviously it's split into grids, and we have these 100 light year cubes, which are sectors, and then each sector is split down into subsectors of 1 light year, and we use those 1 light year cubes as our content space, which means 100 times 100 times 100, that's 1,000,000 light year cubes within 100 cubic light years of space, or 1,000,000 cubic light years, 100 along each edge. That's our content space for the galaxy. But within a star system, we need something similar there as well. So as much as we have the ability to spawn 1,000,000 things per sector in the galaxy, we need some way of dynamically spawning a similar quantity of objects within a single star system. So we want just random asteroids, comets, and alien derelicts, extrasolar things which are just floating through the system. There's so much that you could pack into a star system to flesh it out and make it more of a dynamic space. But in order to do that, obviously we need some kind of grid-based system where we can consistently spawn objects that are the same objects in the same place for every single player, regardless of game. So we'll have a seed system driven by coordinates, the same as we do for the galaxy, and then we need a way of dynamically spawning those objects in. And I was discussing this on Discord today about how we represent objects in space. So anything that is physically explorable by the player, as in you can walk around it, requires a static interior, a physics sim version, which can move around space and bump into things, and a proxy version, which has no physics but is visible out the window. So the sim's hidden, the proxy is visible, and the static interior is for navigation by the player. So everything we add to the galaxy, everything we spawn, needs to have all three of those things in place in order for that to be physically interactable, regardless of where you are within the scope of the game. So if we spawn an asteroid, it needs to have a proxy, so you can see it out the window. It needs to have a physical representation with physics, so that you can bump into it and knock it around. And then if we're making that asteroid big enough that you can walk around on it, then it needs to have some kind of static surface that we can have the player walk around. So we need to make sure that our object spawning system caters for those three requirements. So we need to make sure that, at the very least, we spawn in the physics sim version of the object, and then make sure that a linked proxy object is also spawned, which you can see out the window, so there's actually something to look at. So the grid-based system that we need to build needs to cater for all of those things, so that as you're flying the ship around, then things are appearing on the sensors as you get within range of them. So I was thinking about how many layers deep to go with this, and I think what we'll do is we'll have a sublight version. So the sublight version might be a kilometer grid. So for every kilometer there's a chance of a thing spawning, and obviously we extend that grid out to a certain radius around the ship, so that as you're orbiting around a planet, you'll see things like satellites or other small objects within a planet's orbit. So we could potentially spawn millions of satellites around a heavily populated planet, because those things don't exist until the ship is in range of them, because they're not actually spawning in or being represented until the grid system says, there should be a satellite here, which allows us to go super deep in terms of the amount of, or super dense rather, in terms of the amount of content that we're cramming into a planetary orbit, without filling up the RAM and crashing the game. But then we also need kind of like a medium scale solution as well, where if you're FTLing around a system at kind of low FTL speeds, then we need objects that are, I guess, slightly bigger, like medium-sized objects, things like comets and larger asteroids that are visible from a further distance out. Obviously, when you're even at a slow FTL speed, you're probably moving at thousands of kilometers per second. So we need to make sure that we have a grid that's big enough to cater for those things. So things are appearing far enough into the distance that you can target them and get to them, before they're gone behind you somewhere. So there's probably two systems that we need to build for that. But we'll start with the small scale one. So what I want to do tonight is I want to work on the actual spawning system itself. So we'll spawn in some objects, make sure that they're physics interactable, and make sure that the ship can collide with them, and that they are represented properly in the world. Planets need to be using this at some point. Right now they're not. I won't move planets to them yet, because that's going to break stuff right before we go live with the patch. But this spawning system can be built in isolation, so we'll go ahead with that. Sorry, just catching up with the chat because I was waffling a lot. Yeah, so to summarize Anasi, it's the ability for us to spawn in small things like asteroids or little satellites, just small stuff that's probably smaller than the ship, within a star system. So as you're flying around at sublight speeds, there are constantly things pinging up on the short range sensors that you're finding around a planet. So we'll probably take the planet's hill radius and we'll use that initially as our spawn space. So you'll find that the hill radius of the planet is obviously where things have been captured, and that's where we'll spawn those objects. At larger scales, we'll probably spawn them between planets as well, at a much lower density. So there's always something there to find. Because the whole goal here, and again going back to Obsidian Ant's video, is that star systems are huge, complex things that are absolutely filled with stuff, and most of the time in gaming, they're not. You might have planets and moons and the occasional larger object, maybe even comets, but star systems are much busier places than that, and they should have a lot more stuff than that. So we need to make sure that we keep adding layers and layers of density to star systems, based on the relative speed that you're moving through that system. So there needs to be a sublight content density, and then it needs to be a medium FTL content density, and then obviously when you're fully throttled on the FTL, stars themselves become the content density. But yeah, so that's the plan. Moons require a different solution. So moons and multi-star systems require a different data structure. So we need to completely change our data structure to be barycenter driven rather than using the star as the central object. So once we're using barycenters as our anchor point for a star system, we can then have multiple barycenters with multiple objects around them, like stars, planets, and moons. We need to define that data structure and get it refined and optimized before we can think about adding moons. So that's like a couple of patches time kind of thing. Or if I do have time between patches, I might have a go at it. But it's very different from spawning random objects, because spawning a random object, it only exists where you are at the time. Obviously it will always be there, so because it's seed driven, that same object will always be there for every single player, regardless of who's playing the game, because the whole galaxy collapses right down to a single centimeter in terms of its seed space. So we will have object consistency, but it only exists when you're there, which means it doesn't need to be part of the star system data structure itself, because it's not an object that you'd see, say, on the medium range sensors. We're talking about short range stuff here. So when you do a long range scan or a medium range scan, those objects that appear are all part of like the data structure for the star system. So we're stepping beyond that, but it makes it easier to implement ultimately. Yeah. Yes, Judah. So the idea is that you'd have the short range sensors just constantly pinging as you fly around. In fact, they already do constantly ping. So as you cruise around, like low orbit around a planet, or even go for a wider orbit, you'll find that things will be pinging up on the short range sensors that are things you can fly up to and interact with. It could just be an asteroid, it might be an alien derelict, that there will be just things that randomly spawn, and they'll be relevant to the environment as well. So we're not just going to randomly spawn alien derelicts everywhere. There'll be some relevance to what we spawn and why. Yeah, maybe even seagulls, yeah. Right, so we're doing this from scratch, so I'm just going to hop into Engine, and we'll start defining some stuff. So the first thing we need to do is we need to have an object spawn the proxy of itself. Now we've got, because we're going to have to borrow a bunch of code from our ship and shuttle proxies. Yeah, so we're doing these relative transforms between the physics sim object and the object that you can see out the window, based on the coordinates of the ship. So we need to do this same work for the proxy of every single object we add. So we're going to start off with just some cubes and some spheres and just place them in the galaxy around the ship and just see what we can do with that. I think I might actually spawn one just manually to begin with, and then we'll see about spawning them dynamically. So once we've got the objects spawning and network replicated so both players can see them, then we can start looking towards the grid system and making them spawn consistently every time in the same place. And I suppose we'll also need to start recording interaction with those objects too. For example, one of the things that we could be spawning could be an asteroid with a particularly valuable mineral on it. If you choose to then mine that asteroid and exhaust the mineral that it is contained, then we need to make sure we save the coordinates of that asteroid and then use that as our way of identifying like what interaction you've had with it. There's a risk there of generating massive structs with like every asteroid you've ever interacted with needs to be saved. But we'll have a look about managing scale with that. Ultimately, we only want to save things that have been interacted with and not just stumbled across. So, but yeah, that's kind of another bit further down the line. Right, so let's just make a generic class for proxy objects. And yeah, so this needs to work slightly differently in the sense that we're not getting the location of our ship that we're on. We need to get the location of the object that we've spawned. So these two objects need to be very much tied together. So I imagine what we'll do is we'll spawn the proxy from the simulation version of the object, which means we also need, I guess we'll use the shuttle version of this, that one. Yeah, so we have the space object, which is the physicalized version. Actually, we've got that as a pawn. We don't really want that as a pawn. That should be an actor. So let's reparent that a minute. So just parent that to actor, because we don't need to care about movement components or anything like that. And most of this we will delete. We don't care about movements, we don't care about helm controls, we don't care about any of that. Don't care about that. Keep that one for a minute. Don't care about save data. Yes, spaceborne creatures are also one of the things that we'll be making this from. Actually, that reminds me. I downloaded a plugin yonks ago. That one I think it was. Can't remember which one. I was messing about with some of these fractals, and I found one that was very much like a space creature, and I thought this would be a great thing to spawn as like space coral almost. pop in some random ambient light a minute. Was it? Oh yeah, it might have been this one actually. Yeah, so the idea was that we can spawn in these really cool fractal-like structures and treat them as weird kind of coral-like creatures in space. So I did Delta, yeah. I had a debate with Claire about it, about what constitutes as a coral, and you know, is it something that could exist? But I just like the idea that it could be some kind of space creature that gets its energy from its local star, and it metabolizes whatever happens to be like in a ring around a planet. But yeah, I thought it's a nice way of making something weird and spacey, and I'm sure you could. There was a seed. I'm sure there was a seed somewhere. Yeah, that basically. So we can obviously randomize the objects and make it random shapes and such. If we obviously bound this, you know, within certain boundaries, then we can make sure that it doesn't generate anything too weird looking. But yeah, I mean, it would be quite interesting to fly around this. Don't know why it's gone so flat. You know, as a weird space creature. Yeah, like a space amoeba. But yeah, so that sort of thing. So we would spawn this in, obviously invisible and as a physics object, so you can just like bounce into it. And then visually out the window you see the actual proper physical representation of it. So yes, that's one of the things that we can do and will do, I think. So if we go back to this. So we're spawning this pretty much immediately in front of the ship in a new game. So that's slightly above the bridge, and then if we go minus 20,000, yeah, that should put it 200 meters in front of the ship. Okay, and then what we want to do is, and this is where it gets tricky with replication, is we need to be able to tell the proxy objects where it is relative to this, which means where we're broadcasting ship state, we need to change this. So we're broadcasting this to the proxy instead. And I think I might drop that down to 30 frames a second. Obviously, the more often you do this, the heavier it gets. So it would mean the rotation and location of that object would be updated at 30 frames a second. Don't need autopilot, don't need throttle, don't need nav stuffs, don't need any of that. I don't need electrical things, that's not pinned anyway. No warp on this object, so that doesn't need to be there either. Okay, so that simplifies it somewhat. Yeah, I think it's not liquid water they need so much, more so a solvent. I'm by no means an exobiologist, so I'm only just regurgitating stuff I've seen YouTube videos on. But as I understand it, as long as there's some kind of solvent at play, then it need not necessarily be H2O, i.e. Xenomorphs who use acid for blood. I think in lore they're supposed to be silicon-based life forms. Broadcast object transform. Yeah, so we're not going to need that. Because these objects are going to be quite transient in the sense that because they're going to spawn in and disappear relatively quickly, we don't really need to care about where they are in the galaxy because we're only dealing with the local system, which means we need to take our proxy, so we need to spawn that first. Ideally that needs to be a separate object, so spawn actor from class, and then we'll do proxy object. And it doesn't really matter where it is initially, and we'll handle all the collisions and things on the class itself. Okay, and then we will promote that to a variable. So I'm trying to think in terms of multiplayer here. Multiplayer makes everything 10 times more difficult. So as an actor spawned by the server, it should have server authority to spawn other actors, which means it should hold on to that reference. As long as the proxy is replicating, it should be alright. That said, on this particular actor, I think we want to replicate movement. We don't want it to net load on the client, because the client has no say over what happens with objects that are server side. Okay, so that handles replication of the object itself. I think we'll probably make the object mesh the root object. Obviously right now this is just dealing with a static mesh that's bobbing around in space. Once we start adding data to that, such as what is it, what's it made of, can you shoot it, will it blow up, that sort of thing, then obviously we need to start holding more data on that, so we don't want that either. Normally if you set the mesh itself as the root, it handles replication better with physics movement. At least that's what I found. Right, I'll grab that, pop that in there. Okay, actually if we cast to it so we have a reference to the actual class. Might not need to because we're actually constructing that. Actually no, I think that should already be there. So if we set up our transform, so object transform, and make sure we can grab that. Yes, that's already cast to, so that's fine. Right, so first we spawn the object, and then we start telling it where it needs to be. So on our function here, all we need to do is get a reference to our object. And set object transform. Okay, so that just updates that. And then on the proxy object, we replace this just that, because we still need to know where the ship is. The reason we're doing this is because obviously we move space around the ship, so we need to know the exact orientation of the ship in order to know where to put the object in space. Yeah, so we can just skip all that and just do that. So these offsets here represent how far below the world origin the interior of that object is. So the shuttle, for example, is 50,000 units below the Magellan, which is why we need to offset the location of the object out the window by 50,000 units so that it is in line with the interior of the thing that you want to see it from. So all we're doing here is we're just setting the transform of the proxy object, and yeah, setting the visibility of that as well. So that, oh, hang on. Actually, no, we don't need to do that. Yeah, we don't need to do that because it's always going to be relevant. Exactly, Dave, yeah. Right. Right, so we've got our local movement being calculated. We've got the proxy object location being updated, both of which are happening at 30 FPS. having them both update at the same speed might induce a bit of jitter, so I might increase this one to 60 just to make sure that we're not trying to update at the same time as we're updating this one. Yeah, so the other thing that occurs to me actually is that blah blah blah, yeah. Don't care about that. Yeah, I'm just thinking about how we go about customizing the proxy object on a per object basis. So obviously this is going to be the master class for the proxy and the sim versions of any object. So we're going to have to make child classes of this. So those child classes need to handle things like what is the mesh exactly. So let's just let's make it an editor cube for now. To find the right cube of all these cubes. It's not that one. Come on, tell me where it is. Engine mesh, it's that one. That's all I want. Okay, so yeah, so that's the sim mesh. Just so we don't get confused. So that's the mesh that's running at full physics. So let's just make sure that we are actually simulating physics. So simulating physics, we don't need to care about gravity, blah blah blah. So it is of object Starship, so only things in the Starship collision group will collide with one another. That means that they're not going to be affecting the interior at all. Yep, so that's fine. And on the proxy version, obviously we want the same mesh at the same scale, and then this one should not have any collisions at all. So it doesn't simulate physics, don't have any gravity, and it has no collision at all. Because essentially it's a hologram. Right, so if we drag that into the world, let's find it again a minute. I'll make a new folder for this actually. We're developing in the wrong folder there. So we're bringing in our space object. It doesn't really matter where we put it because on begin play we are telling it specifically where it needs to be. So that's kind of irrelevant for now, but we're telling it where it needs to be within local space. So that will move it on begin play. So that should, if we can see it, be working. Let's just set it to one client for now. Thank you, Sophie. As always, you are awesome. There, have a heart. Very much appreciated. So we're looking for a cube. I probably should have made it bigger. I will make it bigger. But basically that's what's happening with the shuttle. So the shuttle sim object has a corresponding proxy object. So what you see up there isn't a physical object, it's just a hologram of that object. It's got no collisions and it's got no representation other than the fact you can see it. So we should have a cube that is the same. Right, let's make it huge. We're working on dynamically spawning objects for local space. So as you explore through a star system, we want random stuff to be within your proximity. So if it's like a planet and it's an inhabited planet, then obviously we want that planet's orbit to be filled with artificial satellites. So this is how we would spawn in those artificial satellites when you're within range of them, rather than having to pre-calculate where they are and spawn them, you know, as you arrive in the system, which is obviously a huge data overhead, and you know, will overload RAM and VRAM and cause all sorts of issues. But by doing it dynamically based on where the ship is, it means we're essentially streaming objects in and out as you move around, which means that we have practically unlimited density of objects within a system because they only exist when you're near them. That's the plan. Scale, that's what I was doing, wasn't it? So let's make this thing 100 times larger. Let's see whether or not it's actually there. It might actually be set to be invisible to begin with, which also won't help. Yeah, I think that actually might be the problem. I do believe I set them to be, yeah, not visible. I thought that was it then, it was my pointer. Okay, it's still not seeing a cube, so if we turn on this one so we can see it. Make sure it's actually there. Yeah, so it's definitely moving it to where it needs to be. Right. Time for some debugs, I think. So we're spawning our proxy object, setting a reference to it, and then we are doing our looping event, and then we are setting that on the proxy object. So I guess in order to verify that that's actually working, we need to verify that that's actually correct. So let's do some spam. Okay, so that's where it reckons it is. But where is that? See, that's our static shuttle interior there that we are falling past. So the fact that we're getting a value at all means that this is definitely being updated by the server. So that's something at least. I do wonder whether it's resetting the scale. So let's just scale that up even more. I'm still not seeing a giant cube. I can actually, that's a good idea. Yeah, let's make it glow. And we will also just to make sure we are actually spawning it like somewhere where we can actually see it. Just do that, and also in case it's being hidden somewhere else, make sure that it's definitely visible. I think it's now so big that we're inside it. Actually, one thing, just looking at those coordinates, is those coordinates are far too far from where they should be. The next demo update will be as soon as it's ready, and I know that's a cop-out answer, but yeah, I mean imminently. We've just got a couple more things to do. Mostly at the moment I'm just bug fixing, so as soon as all the bugs are fixed, then we can go live. And if you want to see what that looks like, it's this lot. So specifically, there's a few blocks that are preventing the demo from being updated. This is a big one. Players don't have their customization at the moment, so I need to fix that. And also this one, both of these bugs are essentially the same bug, so they'll both be fixed at the same time. But that's one of our blocks at the moment. And we've got a few major bugs here that I want to get fixed for the demo. So once all these are cleared, then we can go live with the demo update. So really, it's how long will it take me to fix all of this, plus deal with any new ones that have been raised. That's how long it will be. No, the backers are a huge help. So our backer community have development builds for the game, and they're always testing and raising bugs and giving me lots of work to do. They keep me honest. Hey, you're welcome. Yeah, probably. Predominantly, this demo update is going to include VR. It's room scale at the moment, so there's no seated VR yet, so it's fully room scale VR. White dwarf stars, completely overhauled graphics. We now have Lumen enabled, or screen space for real-time GI, and just a whole bunch of optimizations. VR is obviously the big thing for this update. But yeah, the white dwarfs have brought with them some really nice nebulas, so that's exciting to go and look at. I think I've just worked out what's going wrong here, actually. Oh no, that is right. So let's get rid of that. We don't need that. Yeah, so that's where the object is in kilometers. And obviously we times that by 100,000 to convert that into centimeters. And that's the real world location of this object, down to the centimeter within the system space. So that is quite rightly what we're broadcasting. It's where we are right now. Assuming that we are, actually, that's local coordinates. This should be the same, so because the relative location between our object transform and the location of the ship, the vector that we're generating from this isn't going to be a massive number. It shouldn't be this, basically. This is a huge distance in kilometers, which means that this object is absolutely, hundreds and hundreds of kilometers away, thousands even. It should be dozens of kilometers, or dozens of meters even, not that. So that's obviously wrong. So if we skip that a minute, and just compare that to the shuttle. Don't think we've got that to hand. Yeah, so if we do a print string on that, see, this shouldn't be a big number. No, look, so you can see the offset. Obviously, this is both the shuttle and the ship that it's offsetting, but that's a much smaller vector. which means one of them is wrong. Okay. Okay, so that's the number we're expecting to see. And we are seeing a much bigger number. So it might very well be that this could be wrong. Let's just check a minute. Yes. We'll be doing it Saturday and Sunday Christmas week, Delta. I imagine what I'll probably do is I'll probably start streaming at the usual time around about 8 PM on the Saturday, and then probably continue through till midnight on the Sunday. So it's actually 28 hours. Because obviously we'll be doing a Sunday stream anyway, so I may as well just carry on through what would have been the Sunday stream and then just end at the usual time, if I'm still awake by that point. So that would be Saturdays. So that'd be the 27th at 8 PM UK time through to midnight, obviously on the Sunday afterwards. So 27th and 28th. Ah, look, there's the problem. So our ship location's coming up with all the 9s. Yeah, if you want to see the surfaces, so right now we're in orbit around Earth. There is Earth. And if I run through this little portal, we're now on Earth. Obviously, there's no atmosphere at the moment, and you know, all the terrain and everything is very much work in progress, but this is Earth. Hurrah, hurrah. So as you can see, I mean, generation time is quick. So I'm on the planet, now I'm back on the ship. It's really that fast. But there's a lot of work to do yet with planetary landings. The test version is very much just a test version. Right, so the issue we're having is this. So we're trying to get player controller. This is an awkward one actually, because we need to know what ship the local player is on. So really, this needs to not replicate, because this is the visual representation. Oh yeah, it's already set to not replicate, so that's correct. Because this this proxy object needs to be in a different position depending on what ship you're on at the time. So if one player is on the shuttle and one player is on the main ship, then that proxy version of this cube needs to be in a different location physically depending on which ship you're on. Because obviously there's only one sim object and then there's one proxy object, but clients need to see that proxy differently. So I mean, that... See, we should be getting that, though. I mean, that should be the correct controller. I'm a little confused as to why this is reporting an invalid location, because... I mean, let's just force it to 0 a minute. Oh wait, unless... Oh, I think I know what it's doing. I think that's actually me removing the reference to game state. So, because we're not casting to it when we set the variable, because we're not setting the variable anymore, and we actually need to do that. Yeah, that should do it, hopefully. It should give us our cube. So game state's now reporting the correct location, so that's right. Okay, still not seeing a cube, but we're getting the right numbers, which means if we take our transformed vector, this should now be a much smaller number, which it is not. Yeah, or deletes Mooning Spartan, because that's happened. I always try and leave my computer like just with a notepad window open, so that if the cat jumps on the keyboard, all we get is notepad spam and not suddenly randomly deleted classes in Unreal Engine. Currently, yes, in the demo you cannot land on planets. Planetary landings are the test that we're currently doing in the dev build. We're not going to add that to the demo yet, because as you just saw, it's very, very early in the development process, and it's not really representative of what it is we want to build for our final solution. So we will save that until it's a little bit more polished. Right, okay, so we need better debug spam here. So we want to print text, and we want to format the text. So we want object coordinates, which will be that, and then we want ship coordinates, which will be that. So that's the coordinates to string. So that's where the object is, and that's where the ship is. So again, these two vectors should be very, very close together, unless I've pasted something wrong somewhere. So I'm just looking at these two vectors. They are roughly aligned, but well, they're very marginally different. Let me take the coordinates there. So we know that that's exactly where the ship is. And then if we replace that, so this should put the cube literally on top of the ship. So we should have a transformed vector of 0, 0, 0 because they're both in the same location. Okay, so yes, question mark. Why is there a red shuttle? Oh, I know why. It's because the construction script sets the mesh. Right. Okay. So yes, we have that. Yes, we have that. Yeah, it's ever so slightly jittery compared to the shuttle, because of that combined 30 FPS update speed, or 30 Hertz rather. So I think I'll set 60 Hertz on the sim version. That should make it smoother. Right, so just to test this then, if we go into our shuttle. So obviously the shuttle is spiraling because we rammed it. Ignore the other one. So that's the static one that we need to hide. And turn the torch on a minute. And that's the proxy Magellan you can see below us. But we should also see a red shuttle somewhere out there. Okay. Right, so that one looks to be tied to, yeah, it's tied to the physics, no, to the static interior, which is no good. So when we go into the shuttle, we should see that other one from the perspective of the shuttle, not the perspective of the ship. Which is also spiraling out of control, just for good measure. Right. So get rid of that, because that was replacing our cube. And then we need to move the cube up a bit and forward a bit. So if we do plus 1000. Actually, no, we won't do that. Right, yeah, so we want it 10 meters up. And I guess we'll stick it 10 meters forwards as well. Because we're at a weird rotation, obviously up in the Z direction isn't necessarily up relative to the ship, so we get that rotation and we get our forward and our up vectors and times them accordingly. So this should put it 10 meters up and 10 meters forward of the bridge. And we don't need that debug spam anymore, so that can go away. Speaking of debug spam, I wrote a whole new system just for outputting debug spam. Bye, cube. It's obviously collided with something and it's off on its merry way. Yeah, so that green text at the top of the screen there, is because in a packaged game, none of the debug outputs are actually represented on screen. It's just part of when you package with a shipping profile, Unreal Engine strips all that out. So we've had no way of debugging some of our issues because there is no print screen available. So I've had to make my own network replicated print screen. It's another one of those things that you don't plan on doing but end up having to do anyway. So actually I think that should have been that way. I'm trying to get, oh no, there goes the cube. I don't think it's high enough. I need the cube to be static. Yeah, what I'm going to have is different systems with their own debug, or rather like audit log, that we can turn on and off. Things like the chairs. So the chairs are, I know this sounds weird, by far the most complex, annoying things so far in this game are the chairs. The chairs have so many problems because we're inheriting them, or rather we're possessing them as a pawn, so that they inherit mouse movements and everything, so you can spin around in the chair and all that stuff, and wheel around in them as wheelie chairs. But in order to do that, we're unpossessing the actual player character, and then we're storing that player character on top of the bridge window just to get it out of the way so no one walks into it. And then when you leave the chair, we have to then move the original character back to the chair exit point, unpossess the chair, repossess the player character, and then obviously clear all the possession on the chair, make sure it's available to be sat in by other players. There is a lot of complexity that goes into those chairs. It's stupid. Like, you've got an entire starship's worth of systems, and they are nowhere near as complex as the chairs. Game dev stuff. Right, there is a cube. The cube is where we want it to be. So if we now get in the shuttle, we should see that cube below us from the perspective of that shuttle's front window. Oh, no, it's the back of the shuttle. So it should, right, so we can't. So there should be a cube here, which means the cube is still up there somewhere. So if we jump off, we'll fall through the proxy. So I imagine what it's not doing is updating this, although this is running on a loop, so we should be updating this. Let's just verify that we are in fact changing vessels. So right now it says we're on vessel 0, which is right because we're on the Magellan, and it should go to 1 when we go through the portal, like that. So we're now on vessel 1. The Sol system didn't load for some reason. It does that sometimes when running it from within the editor. Yes, AJ, thank you. Yeah, there's a few issues there, and I imagine most of those issues are going to be fixed all at once, because a lot of them have the same root cause. So once I've fixed the main problem with the character customization not replicating properly, I'll then hit all the chair bugs all at once. Right, so there's definitely no cube there. Okay. Hang on, I'm trying to get my head around this now. So if that's there, let's just try moving that down there a minute. Hang on, reload again. Right, so the cube's gone from there. Now that's interesting actually, because we are still on ship 0, so it shouldn't be trying to offset it. But it is now there. Okay, so this is correct, that's where it should be. But it should also be there as well. Oh, hang on, it's still saying we're 1. So now we're 0. Which I'm assuming means that it is down below us. So if we just jump off a minute to see. Yeah, it's still down there. Right, so probably actually that is probably then that needs to be minus 1050 because the awkward thing with the Magellan, and this is one of those really annoying hindsight things. When I modelled the Magellan, I placed the world origin in the centre of the bridge. Which made sense originally because the ship was in fact circular. So it made sense. Put the origin in the middle. Now obviously as the ship's evolved and changed over the years, we've stretched it out, we've made it taller and wider. So the actual centre of mass should be in the midpoint, like between, in the middle of the ring, which is 10 meters below the center of the bridge. So our world origin is 10 meters off, 1050 to be exact. So that means we need to move the space object that far down because that's where the center of the ship actually is with respect to the cube. The shuttle, however, is obviously 50,000 centimeters below that, so that needs to be offset by that much. So we just need to make sure that we get the offsets right. In future, I will make sure that we always set the world origin for the modelling at the geometric centre of the ship, which I have done for the Caravella, so we're okay on that one. But yeah, it does add a layer of confusion to things. I need to figure out why it keeps not loading the Sol system randomly when playing for the editor. Alright, so there's no cube there. But there is a cube there, so that one's good. Now when we go back through the portal, that should set us back to 0, and it isn't. So I do that, it still isn't there. Is it instead underneath? No, it's not there. Does that mean it's still underneath all the way? Yeah, it's still down there. Which means it's still trying to do minus 50,000. Why is it doing that? Hang on, let's just make sure that that portal is... Oh, right, that doesn't help. That should be 0. Okay, let's ignore the offset for a minute. See where it actually puts it. Right, so it's put it there. So that makes sense because, again, the midpoint of the ring is down like underneath there. So if we were to align that with the 0 point, we'd have to take it down, which puts it in line with the 0 point on the bridge. So hang on, let's just let's remove our offset vertically a minute. See where, right, so it's putting it, so that is putting it in the world origin. Which of course we don't want it to be. Hang on, getting my head around the math now. Right, so because the center of the ship is 10 meters below the bridge, if we don't have a vertical offset, this cube should be 10 meters. Should be 10 meters down. So it means we need to offset it vertically to be in the right place. No, the other way around. We need to remove. Yes. So, hang on, I will get my head around this. So we need to deduct. Oh no, that was fine actually. No, so all right. Yeah, let's leave that at 0 a minute. And that as well. Right, so this should be on top of the ship's actual origin point, which we know should be below the bridge. So that's putting it right at the world origin, i.e. on top of where the ship is registering itself to be. But that will give you a visual offset which is 10 meters wrong vertically. So the true middle of the ship would be minus 1050. Which should put it 10 meters below the bridge. Which is there. Okay, so that's correct. So if we then add a vertical offset of 1050, that should put it back to the middle of the bridge. No, there it goes. I can see it flying off. Come back, cube. No, that's fine. That's because it's colliding with the physics. So if I just turn off collisions a minute, just so we can get it in the right place. So no collision. It's not where I wanted it to be. That's weird. So is it still underneath? No, now it's gone nowhere. So is that because we are reading the wrong values? Oh, I've just realized what I'm doing. I'm taking our target vessel value, which just so happens to be 1, because that's the ID of the shuttle. It's not that. That's not what we want. That's what we want. It's the current vessel. That's me having a brain fart, I'm afraid. Right, so that should put it back in the middle of the bridge. Which it does. Right, so that's our vertical offset solved. So if we now hop into the shuttle, it should be down there as well. Yeah, so it's also in the middle of the bridge there. Okay. Right, so if we want it to be above the bridge, then if we put 2000s, that's 10 meters above the bridge, and again that would be 20 meters forward of the bridge. Which puts it... oh, I didn't plug it in, did I? And we can set a collision on that one again. Right, so that puts the cube there for the ship, which is correct. And then when we go through the portal to the shuttle, it's also there. Right. So what we've achieved here, I know it probably doesn't look like much, but we now have a single source of truth for where the physical object is in our simulation environment. So every ship, every planet, every station, every rock has a representation in the physics environment, which exists for the purpose of things bouncing off of other things. So you can ram a rock, the ship bounces off of it, etc. So that physics environment needs to exist. So everything has one. But all that's invisible. For you to actually see those objects and where they are, that's actually a relative view based on your perspective on what ship you're on. So as you change between vessels, your perspective out the window changes because you're on a different ship that might be facing a different way. So the proxy version that represents that physical simulated version needs to change its location based on the ship you're on, or shuttle. So that's what we're seeing here. So that's the cube from the position of the shuttle, and then from the position of the Magellan, that cube is in the same place relative to the proxy version of the shuttle there. So So basically, we've reached the position where everything is aligned across the board, and everything knows where everything else is. So that's basically like step one in the process of being able to spawn an object in the world, a physical object that you can ram and interact with, but also have that object visible to all players in all locations. And speaking of all players, we will now do the hilarious thing of testing it in multiplayer, whereby we watch it all fall on its face, as is usually the case in multiplayer. So immediately I can see that the cube is there only on the host. So there's the cube for the host, and the client cannot see it. Only the server is running the check. Yeah, so this is where we need to get into the replication side of things. Move the ship, yeah. Hang on a minute. Let's just get the Sol system loaded so we can see what we're doing. Nope, still no Sol system. Fortunately, it doesn't do this in a packaged game. There we go. There's the Sol system. Right. So if I pop the host there, so the host can see what that's doing. If we just do this a minute. Right. So the client, which won't see Sol because the client can't read the database. So if we move the ship forward, you'll see that the cube stays put, because the cube is managing its own view of the universe. However, if I just move that back a bit, if we just pitch up, we should be able to bop it with the ship. Let me just go all the way to the nose a minute. There we go. So we've now bopped that object. Now obviously we can't see that from the perspective of the client, but from the perspective of the host, that object has now been physically bopped. So off it goes. And if we go back into there, we can see that that object is still there from the ship itself. So one of the things we actually do need to do is we need to build the physics environment for the ship, because if we look at our mesh for the Magellan, obviously it's in pieces at the moment because it was just a quick export that I did. But if we look at the collisions for this, no, that's not the one we want. There. So annoyingly, oh hang on, this is the proxy version. Hold up, wrong mesh. That's why it's got no collisions. So there are two versions of it. Obviously the one you can see and the one which is whacking stuff. This one, the collision mesh looks like this, which is why the cube went through the hull before it got bopped, because the collision mesh is down there. So what I'm going to have to do is very carefully and laboriously place collision hulls all over this mesh to have the tightest collision response possible, because you can't have complex collisions that move with a physics object. So right now they're just very rough collisions, but that's another job that needs doing. One of the many jobs that needs doing. But yeah, so the collisions are rough to say the least for now, but you can at least like fly through the ring and stuff without whacking into anything. Yes, so that's why the box went through the hull. So the question is, how do we make that work from the perspective of the client? Now we know that only the host is running this, and this needs to run on both the client and the server. So I think what we need to do, if we so we don't want to replicate movement, but we do want to load it on the client. So we want to make sure that both the client and the server are running this function, which they are. So we've got both client and server running it. So that's something, at least. And then we need to know that the client and server have the same view of this object. So yeah, so if we get our relative transform, yeah, and then to stop the spam, we'll update it once per second. Right, so you can see the server is putting the object 20 meters in front of the ship and 9.5 meters above it, which is correct, whereas the client is putting that same object miles away. So they're putting the object in different locations, which is not what we want. So we just need to work out which bits, or which one of these bits of information is wrong. So again, if we check, make sure that I bet I know what it is. I bet that probably needs to be a replicated variable. Hang on, let's just try that a sec. Yes, there we go. Right, so client and server can now see the cube in the same place. So there's the cube from the client, and there's the cube from the server. So can they see them in separate locations, which is the big test. So if we grab our client and we run him through to the shuttle. Perfect. So, oh, it's gone. Boo. Oh, I see what's happening. For a brief second then, that was perfect. is it because... Is it because the server's grabbing authority over it? Huh. So it's correct there. It's correct there briefly. Okay. Just make sure that our current vessel check is still working. Exactly, AJ. Right, so both the client and server are reporting ship ID 0, which is correct. That's what we want. So when we go down to the shuttle, the client should remain... Oh. That's interesting. So the client stopped reporting. So client's there. Okay, and the client stops reporting. Oh, is this a net distance squared thing? I bet it is. It's probably this. If we set it to always relevant, that will probably fix that. So every object in a networking environment has a call distance. If you pass beyond that call distance, then it stops replicating. It's to aid in performance. Yeah, that was the problem. So basically, because the shuttle is 50,000 units below the bridge, we are passing beyond the net call distance squared. So then it stops replicating. So that's why the client was no longer broadcasting what ship it was on. But that fixed the problem. So that does mean that all of the objects that we spawn locally need to be always relevant in terms of replication, because like planetary surfaces are even further down below the ship, and if we have something large in orbit that you can see from the surface, we don't want it to suddenly disappear. But yeah, that fixed it. So there is that, and there is that. Just wondering how else I can test this. I think that's pretty much everything ticked off, actually. So just to recap for my own benefit, really. So we're spawning the simulated version of the object that has physics. That is therefore itself spawning the proxy version of itself, and then it's updating its own proxy itself. So it's self-managing its proxy. And then that proxy is replicating to clients based on the ship that the client is currently on, which all seems to be working, which is nice. It's nice when things just work, isn't it? So the next thing is to do that dynamically. Well, actually, we don't. Let's just try turning that off a minute. Make sure it's not hiding it unnecessarily. Shouldn't be, because there shouldn't be anything else in the code that's making it hide. So yeah, that's fine. Still got a cube. Right then. So let's make a spawner for this. Yeah, I guess this is going to be a good test, performance-wise, of how many of these things we can have spawned and replicating and updating their location, and indeed also running physics. We do need them to sleep, so yes. So large objects like big asteroids, they won't actually move physics-wise. Yeah, because what we don't want to happen is you plow into an asteroid, it goes pinging off into the distance, and then when you loop back round, it will respawn it. So you could keep looping and looping, and it will just keep respawning it in the place it started from, and you could keep knocking them off into the distance, and then the one in the distance will just despawn. Although maybe that's not the end of the world. I'm trying to pick what's the lesser of two evils there. I mean, it would be nice to, you could troll an alien species by just ploughing through all of their satellites and just pinging them off the ship as you plough through, which would look good visually. But from a mechanics perspective, if you return to that location, it will just respawn them where they were at their origin point. The alternative to that is to constantly save where they now are, and that's going to bloat save files something crazy, especially if you would go to a star system, bump into a rock, and then from that point on you've saved where that rock is, and you may never go back to that star system ever again, and yet you've still got the location of that rock in your save file taking up hard drive space, which is fine for one rock, but what when you're in your 1000th rock, that save file is going to get huge. So we need to do some balancing there in terms of what's practical and what isn't. Yes, Ian. So the I key on the keyboard used to be a test button for prop interaction on collisions. So what we would do is we would wobble all the props every time the ship received an input. So it would trigger a camera shake and also shake prop objects. And we did that based on radius around a player. So if the object was within visible distance of a player, it would wobble when the ship received an impact, which looked really, really cool. We needed to tune the numbers a bit because it was causing props to go flying off all over the place. Like when you hit I, you'd have like loads of cookies flying around the lounge. But yeah, in principle, yes, it worked. And also, yeah, so crew as well. So when the ship receives an impact, we can easily trigger a stumble event for NPCs. Yeah, easily done, and we'll definitely do that. Hey, Zotbox. I'm jealous of your burger. I'm quite the burger aficionado. Let's just make a test spawner a minute. So what we want to do with this is I never ever use tick on blueprints because it's bad. It's bad juju. Don't do that. Instead, we do timer, either timer by event or timer by function name. If you're doing something a lot and rapidly, I find timer by function is more performant. I've tested this with like 10,000 objects, and there is a noticeable difference between the two. But if it's just like one thing, then a custom event is fine. Spawn thing. Right, so we want to spawn actor from class, and we're going to do sim object. Space object even. And for our spawn transform, I think we'll just randomize that. So if we make a transform, and we'll give it a random rotation. We could do random scale. We'll worry about that. That's another time. So if we just do random float in range, so I'm gonna yeah, similar to the cat spawner but different. So we want, I guess, 200 meters either side of the ship. So up and down, so that's basically all the way around the ship. They could spawn anywhere, but we do want like a keep out zone as well, so we'll do so if that so we'll measure the distance between that vector and the world origin, and if that is less than, let's say 100 meters, and then we'll do it again, basically. Yeah, so if it's less than 100, if it's not, then we're going to do a small delay. Uh, 0.1 will do. Right, so once per second, it's going to spawn a new red cube. If the location that it's picking is within 100 meters of the world origin, then it will just try again. I mean, I could set up a more complex series of floats, but that's probably quicker. So let's see what we get. Just pop test spawner there. So we should start to see proxy objects. Actually, I'm going to get rid of the client in a minute because that's just in the way. Hang on, make sure I did actually set that up. Oh. might be that it's struggling to pick the location. Either that, or we have an authority problem because the object is being spawned by an actor in the world, but that is running on the server, so that should have authority to spawn other actors. Not that I can see any. Let's simplify that a minute. Let's get rid of our check and just have it just spawn stuff, and we'll do it a lot more frequently. So we should see red cubes just appearing everywhere. There we go. And then frame rate should very quickly tank. We set the update rate on proxy back to 30 FPS, or 30 Hertz rather. Then they should all be moving. Oh, hang on, they're all spawning from... Why are they all spawning from the same spot? Oh, of course, because we're we're literally telling it. Yes, of course, we are telling it to spawn in a specific location, which is why they're all appearing in the same place and flying off into the distance. I don't know why the sun's flashing, that's weird, but to be honest, frame rate wise, it's not really dropping much. And that's already a lot of objects, more than we would ever spawn in one go. Although if we're spawning an asteroid ring, well, not an asteroid ring, because asteroid rings are not like this, but small objects within a planetary ring, then we could potentially make them dynamic, which would be nice actually. Being able to, again, even if they reset when you came back later, it would be nice if you were flying through a planetary ring and you had like football-sized objects that were just bouncing off the hull. That would be quite atmospheric. Given how many we've spawned, it's coping remarkably well. Hang on, I need to count those now, just out of interest. Where are we? Right, so we're currently looking at 60 FPS. Obviously that's capped. So uncapped, 70-ish. So we're up to 250. Still running at 60 FPS. Bearing in mind this is going to be hitting the CPU, not the GPU, because it's all physics and timers. So coming up to 500 objects. So here we go, 500, and we've only lost about 20 FPS. So that's not terrible. Yeah, given that all of these cubes both have physics and are updating a proxy at 30 Hertz, that's pretty good. And we're just about 900. There we go. Let's see what it looks like with 1,000. I mean, I would say we've got easy enough object density here for a planetary ring. Okay, so there we go. So we've got 1,000 objects, all of which are updating at 30 Hertz, and we've only lost about 40 FPS. That's yeah, pretty impressive, I would say. Hang on, I need to jump off the ship and see what that looks like from a distance. Oh, I seem to have hit something it doesn't like. So the other test, actually. Apologies for the flashing. If I run into the shuttle, are we still seeing the same point in space, regurgitating cubes? So hang on. So here we are on the shuttle, and apart from the fact the shuttle, yeah, so the shuttle is being knocked about a bit, but yes, they are coming from the same place, so that's good to see. And yeah, the shuttle is not happy. Okay, another successful test. That's true, CSI. I'll make them grey potatoes. So I need to think about where we're spawning this stuff now, actually, because obviously when we spawn the object, it's forcing it to spawn here, which we don't want, because this is this needs to be dynamic. So I suppose the easiest way to do that yeah, so actually what we need to do is take that vector there, and then we need to do that, trying to preserve the fact that that's a float. Right, so if we grab 3 floats, so we can grab our 3 values for our X, Y, and Z. Right, so that's our origin point for the ship, basically. And then each one of these needs to be plus. Well, that's wrong as well. That should have been minus 2000. Yeah, so each one of those needs to be plus or minus a random float. And then we'll make our vector. So now we'll recheck to see whether that's well, actually we need to check whether it's in range of where the ship actually is. So obviously, again, this is only going to work in this one spot right now, but for testing purposes, we'll just see whether we create a shell. And then on this, yes, so on this we'll get rid of that. So we're no longer spawning it there, but we do need, of course, we need to convert that to centimeters. Yeah, so if that, and then that goes in there, and then we need to add, no, not add, times, yeah, multiply each of these by 100,000 because we need to convert it to centimeters. Right, so if that times 100,000 is that far away from there, blah, 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 spawn actor in that location. Okay, we've removed that, so in actual fact, we're not even going to set the actor location and rotation. Instead, we need to set that based on get actor location or do we? I think we do actually, because we are already using that there, so we shouldn't need to. No, I think that's fine without. Right, let's see whether we get a shell of cubes. I'm not seeing a shell of cubes. So again, let's ignore that and just let it spawn them anywhere. Yeah, so we should end up with a whole big thing. Although, where is it putting them? Hang on, let's sure that we're updating that. So that's updating at 30. That's also updating at 30. Right, so hopefully if I move that down a bit, that should stop it flashing. No, still do. No. I imagine that's because we've done that. Right, there we go, it's better. Right, so it's spawning them somewhere. The question is where? Out there, that's where it's spawning them. So it's spawning them and then moving them somewhere. Where is it moving them to? Which would suggest that what I've done here is wrong. Oh, right. Right. So of course this is in centimeters and this is in kilometers. So, right. I see what I've done. So these need to be converted into centimeters to make sure that we're dealing with a consistent unit of measurement. So that's not needed. So that goes to there. That goes to there. Right, so we should now get them all over the place. Well, there's one. Oh no. There they go. Okay. That's okay, so we are definitely ignoring that, aren't we? So every 0.1 of a second it will spawn another one, and we're spawning it within 200 meters of those locations, which should be all around the ship. So we're setting the location and rotation based on that. And then the object we're spawning is this. So it's grabbing a reference to game state there, which it probably doesn't need to do. No, so that can go. We're setting the actor location and rotation, which we don't need to do. Already doing that here, so that's that's already set, so that's not needed either. So we don't need the sequence. So what we're actually doing is we're spawning our proxy. I won't go stick it above. Should be the world origin there. Yeah, so we spawn the proxy and then we start telling the proxy where it is. Okay, so that's spawning it up there. Right, so it should be spawning cubes all over the place. Oh, there's one. Oh, hang on a minute. Okay, so it is spawning cubes. Why? Oh. Okay, why do we have some kind of death ray of cubes? It does look like it, doesn't it? So we're adding... That should not be resulting in a line. Is it because I've reused this node? I mean, I'm sure every time you hit this, it will re-roll the random number, but let's try it without. Oh yeah, there we go. We're starting to build up a nebula of cubes around us. Okay, so basically we have a sphere of cubes spawning around the ship. Seems to be working as intended. That seems a lot further away than 200 meters, though. Like, why are they all the way down here? Have I miscalculated that to be 200 meters? I think I have, haven't I? Yeah, because 1,000 to be 10 meters. Yeah. Right. That's better. So when it comes to deciding the speeds in which the ship can move and the rate in which things need to spawn, we need to think about, I guess, density of objects. So how often are we going to spawn in one of these things? Obviously we need to make sure that we manage consistent spawning, so you get the same object consistently every time. So that's where our grid system's going to have to come into it. Oh look, it's a cube of cubes. Right then, so we've got our units of measurement sorted. We've got all the proxy stuff sorted. So really the next thing we need now is the actual grid. And that's the difficult bit. So I guess we need to decide upon what our grid resolution actually is. See, So the ISS moves at about 7 kilometers per second. Now we don't want the relative ship speed to be that much. I think we're probably doing it in hundreds of meters per second, because we've got this whole, if we are wanting to maintain close quarters combat between vessels, the vessels can't move too quickly. If we have an unlimited throttle, then you could just keep accelerating into infinity, and you end up with these crazy jousting matches in space. We want ship combat to be close quarters. We want it to be slow, methodical, two galleons fighting at sea. So we're going to have to limit what our sublight speeds are. So we can use that figure to drive how often we need to be spawning in objects. Obviously we don't want space to be littered with objects, because that's not realistic, but objects need to be spawning often enough to keep it interesting, especially around planets that may or may not have a civilization that is spacefaring. I think I like the idea of rocking up to, maybe we have a world like Coruscant, so we've got like a city planet, entirely doable. We just generate the terrain as such, but in order for that city planet to be believable from a technological perspective, it's going to have a lot in orbit as well. So we need lots of orbital clutter, lots of satellites and things. Again, like in real low Earth orbit, the distance between satellites is tremendously large. Like if you picture like the next city over, and you try and see a single car in the next city over, that's like a tiny distance compared to how far apart things are in space. I mean, like, you're talking hundreds and hundreds of miles between objects. So it needs to be dense enough to be interesting, but not so dense that it's like unrealistically populated with stuff, because otherwise things like the Kessler syndrome would have already happened. And I think the best way of judging that is based on maximum ship speeds. So if we maybe go, I'm thinking 1 kilometer per second, maybe. That might prove to be a little bit on the fast side. So then if we had a kilometer grid, then we need to spawn and update that grid as the player ship moves through it. So the same way as we do with the galaxy, basically. So we've got a 3x3x3 grid of sectors that are constantly being regenerated as the ship moves through the galaxy. So we need that same 3x3x3 grid of sublight stuff. So the question is, how big do we make sectors from a planet's perspective? We could do something like 100 kilometers. So where we've got 100 light years for our galactic sectors, maybe 100 kilometers for our local sectors, and then that's a million potential object spawn locations within that 100 kilometer cube. It's probably a decent enough number, and then it will take you 100 seconds to pass through one local sector if you're moving at maximum sublight speed. I think that should work. And then we're not having to regenerate all those objects too often. And because it's not a galactic sector that has, say, upwards of 8,000 to 10,000 stars in it, we're never going to have that many objects within that 100 kilometers. So we can keep our object counts much lower, and then have from the short range sensors perspective, have those objects probably within about 150 kilometer range. But then that doesn't seem like very far. So maybe 1,000 kilometers per sector, which gives us 1,500 kilometers of short-range sensor pickup for small objects. That's going to require some testing, I reckon. Good night, CSI. Have a good one. Yes, Quicosme, you'd think so, wouldn't you? I mean, I guess you see it in planetary rings. You know, planetary rings are dust and small particles, and anything larger than dust and small particles severely disrupts the ring and creates gaps in rings. So, yeah, so something the size of a starship would probably, over the course of a few thousand years, quite happily create its own gap in a planetary ring and collect lots of dust and rubble on its hull. And obviously that spirals over time, because the more it collects, the more mass it has, and obviously that's just an exponential growth, isn't it? But we won't be simulating that. That would be madness. Okay, then. So we need what is essentially another galaxy gen, but a galaxy gen driven by our local coordinates rather than our galactic coordinates. Okay, so it's probably easier if we take our galaxy gen and just duplicate it and work on it from there. Galaxy systems, galaxy gen, there. Sublight jet gen. Okay. So let's just go through this and cull stuff. Okay, so there's a few factors that we need to roll into this. We need to broadcast what it is we're generating. That needs to be local, so it's happening on the client, so that we have that data available to the sensors. We also need to weight the spawn rates based on proximity of a planet, because we want to simulate planets having collected stuff. So if we're spawning just random rocks in space, then the density of that needs to generally increase where planets are. In an ideal world, we need like Trojans and such. Obviously, like Jupiter's got its Lagrange clouds and Trojans and things, as does Earth. Actually, I didn't know that till recently. I rather naively thought the Lagrange clouds in Elite Dangerous were just like an Elite Dangerous thing. I didn't realize they were actually an actual thing for Earth. Like, Earth has a Lagrange cloud. It's very wispy and faint, but it does have one, which is quite cool. I didn't know that. So we'll need locations like that. So we need to tell the system where these points of interest are, so that it can increase its density curves in those regions. So I guess we need we need to pre-generate a list of vectors. So like, vector that there's a gas giant there. Next vector, there's a terrestrial world there about the size and mass of Earth. So if we're telling it where these objects are, then the bigger and more massive the object is, then it needs to up the spawn rate in those locations. Ah, nice. Yeah, so we can be querying the actual star system itself to work out what the spawn rate needs to be based on the proximity of things like Lagrange points, which we're not calculating yet, so we need to calculate them first and then we can roll that into the equation. But yeah, I think that's probably the most organic way of doing it, so that the structure of the star system is directly impacting the density of the object spawn. And then we have things like the Kuiper belt. So obviously, like the asteroid belt, the Kuiper belt, as much as it's littered with icy bodies, it's littered with icy bodies which are tremendously far apart. It's not really a Kuiper belt, it's more of a Kuiper region where you find a scattering of cold icy objects. But again, we need to roll that into the system so that when the ship is within those regions, it starts to spawn just random icy rocks that are indicative and relevant to a Kuiper belt star region. We might even be able to actually use this same system to drive planetary rings as well, because if this cubic system is aware of where the ring is on a planet, then it can significantly up the spawn rate in the region of the ring, so it can be spawning larger asteroids and larger objects, I guess, which would be equivalent to small moons within rings. But yeah, I'll have a think on that. This might not be the system to use for that, but we shall see. Right, so first things first, we need to just check what we're doing here. So for a start, we don't want the galactic coordinates, we want the local coordinates. And we'll change this up. Thank you, Writing Gamer. Very much appreciated. See ya, Cookers Me. Have a good one. And yeah, a Kuiper point cloud. Like it. I think we're going to just rename these variables. That's probably the easier way of doing this, because a bunch of the logic's going to be the same. It's just that we're dealing with local coordinates, not galactic coordinates. So we'll have sector IDs within a system, and again, like with the sector ID for the galaxy gen, the local system sector ID will also have a seed associated with it, and that seed is driven by the coordinates themselves. So in this case, we are doing our 100 light year cube. it's slightly awkward where we're on the 0 line because we want, and I suppose this might not matter as much for this particular system, but we wanted Sag A to be in the middle of sector 000, because we wanted Sag A to be the literal geometric center of the galaxy. Otherwise it would be like in the far corner of a cube. But in order to make it right in the middle of a cube, obviously the cube goes from like minus 49 to 49, which is why we're dividing by 50 here, but only if we're under 100. It just means that we have, so every single sector goes from 100 to 50 to 150, and then 150 to 250, with the like 100, 200, 300 being the midpoint. But on the 0 line, you've got this big cross in the middle of the galaxy where it goes from 0 to 49 along each axis, and that persists obviously all the way along any 0 line. So we'd have that same here as well. But I think we're going to have to maybe add just an additional 0 to all of these, and again base those on 1,000 kilometers rather than 100 light years. 1,000 kilometers just feels like a better size for local space. I'll see you, Delta. Have a good one. Enjoy your Christmas dinner. It's only a few days to go now, actually. I think the pre-Christmas panic is starting to set in. It's like, have we got everything? Have we done anything? Everything we need to do? And yeah, I'm sure we have. I'll leave it at 100 for now, so we don't break the system yet. So we don't need a density map. So we're using a 2D density map for the galaxy, so we don't need that for our system. We don't need to be grabbing any databases. We don't need to be grabbing any of those databases either, because again this is all just dynamic stuff, so that immediately makes it a lot more simplistic. We will need, so we don't need to generate any single sector stuff. We will need a new event for this, so we're going to need a payload for our array of objects, so we're going to need a struct for that. Yes, that should be what we need there. So we got, so our single sector stuff should be irrelevant. Yeah, so none of that's needed. So we don't need any of that. Don't need any of that debug. Okay, yeah, so our sector offsets are, this should be easy enough just to add some extra zeros in there to make those 1,000 kilometers in size. Fortunately, I made it a macro, so that's easy to change. So what are we doing? So we start our track of the ship states, We then generate our sectors. We grab our sector midpoint, which again, just add some zeros. We need a different struct array for that. Don't need that. We don't need that. Yep, so it is any of the texture stuff. So that gets rid of all of that. Okay, and do our async sort of the data, which we'll still do because for the sensors, we kind of want to see what's in range, which means we need to be listing things in order, and the easiest way to do that is just to sort the array by distance. So we'll still do the whole array sort thing, although this is significantly more streamlined now. Okay. And then the sector generation code is going to be very different. So the galactic coordinate system is Sag centric. So as far as all of the units of measurement are concerned, I guess within the game's lore as well, we decided that it was more practical from a navigation perspective to base the navigation system on the biggest, heaviest object in the galaxy, which of course is Sag, and base all the coordinates based on that. So galactic north is basically Earth towards Sag. So in terms of the rotation, we're using a straight line between Earth and Sag. That's our north line. But Sag is the middle, and that's where 000 lives. Yeah, it's humans have a habit of centering everything on Earth, but yeah, in 200 years' time, we've decided that's a stupid idea in the galactic space. It's you should always base your measurement system on the biggest, most solid thing. The Magellan line, yeah. True that. Right, so this is where we generate all of our random seeds for all of our different types of star. Now again, a lot of this is completely irrelevant when it comes to spawning objects, but I am wondering whether we keep the same structure so that we have like asteroids on a separate random stream to say comets, so that we can add additional classes of object without affecting the location of objects previous. And that's kind of how we've managed the galaxy. So we can add an entirely new class of star without having to rebuild the galaxy or reset the galaxy or anything like that, because each class of star is managed by its own random stream. And as long as we always add new ones at the bottom, then they'll check when it tries to spawn a star. If that location's already taken up by another star, it will just try again to spawn one somewhere else. So we won't affect any other star if we always put it at the end. That's the logic anyway. So that can stay. I guess this one is going to be determining a sector's local region. So the sector types are going to be things like planetary ring, Lagrange point, open space, that sort of thing, planetary orbit, so that we can define a class of local sector and affect what we spawn there accordingly. Because really, like when it comes to a planet, we want a shell around that planet, so a shell of sectors that will enclose things like a low Earth orbit shell that has things like satellites, and then we have like higher orbital shells, like we'd have a geostationary orbital shell where things get spawned. So we can calculate that here and set those sectors up as required, which is where the density calculation would come into that. So we determine this type of sector, and that defines the density. We don't need to care about political state, so that can just get deleted. We're not going to be doing anything with that. So we don't have real world data, we don't have that. So procedural locus, we're not going to be doing that, not going to be doing that or that. Yeah, may as well get rid of that. So that simplifies that a little bit. Then we'll go through and actually generate each class of object. So this is going to be like asteroid, satellite, comet, etc., etc., etc. Although comets will be something we generate on probably the medium range cube, a sector cube. That'll be handled by the randomness. So obviously in amongst the structured setup of this, we do random dice rolls as well. So data only is irrelevant. Don't need that. Which means we don't need that Boolean. So we don't need that, don't need that, don't need that. Probably don't need that either, but we'll modify that accordingly. Because what we can do actually, see, we can use this system for a few different things. So as much as we can use it for spawning objects, we can also use it to define the ship's location within a system. So like here, if we know here where in the system we are, so like if we are, say, in the Kuiper Belt region, for example, then when we build the description, we can actually tell the game that the ship is currently in a Kuiper Belt region, because we've determined that from the region of the sector. I suppose it would be prudent at this point to look at how many cubes we're dealing with. For that, we shall use our length converter. Yeah, so we want to convert 0.5 light years, because each star system is 1 light year in diameter. So 0.5 light years from the middle to the edge, and it's a cube. So we need to work out how much that goes into 1,000, which is going to be a ridiculous number, isn't it? Where is my thing? Right, so I'll pop that in there. So divide that by 1,000. Right, so 4.7 billion sectors. That's actually not too bad, because our seed space far exceeds that, and for the most part star systems are not that big in terms of their radius. So yeah, so I think we'll be okay there in terms of how many sectors we actually have within a star system, because we're not using 32-bit integers for our seeds. We're using 128-bit vector-driven seed. So yeah, so that should fit no problem. So we can split the entirety of a star system into that. So let's just let's grab our length converter again. So one light year would be that. So if we divide that by 1,000 and equals that cubed, so that's a really big number. So that's how many sectors there would be within our cube. That's madness. So basically that's how many individual seeds would be needed. I forget now how many zeros are on a 128-bit seed. I think it's more than this, so I think we should be fine there. But it also loops round, so the outer, like if our seed system, or our number of available seeds, is less than this, then when it reaches the edge of the seed region, it will just start again. But that wouldn't really affect it in the outskirts of a system, because there's going to be nothing there anyway, so it should be fine. This is only really relevant within the star system itself. 1,000, yeah, 1,000. So yeah, and then obviously each one of these will have either a kilometer resolution. Hang on, how much is that? So equals 1,000 cubed. Okay, so that's a billion. So within within our 1,000 kilometer cube, that's a billion potential objects that we can spawn within that cube. Practically we can't, because obviously we have to spawn those objects and then hold those objects in memory and manage them, etc., etc. So it's probably realistically no more than a couple of hundred, but obviously there's a lot of space there where things can be spawned. Alright then, so that's fine. Yeah, that's how I make typos. I type too quick sometimes. Okay. So in order for this to work, we're going to have to kind of step through it step by step a little bit. And probably generate a lot of debug spam while we're at it. I suppose the other thing that we need to do is also despawn these objects. So yeah, so we need to track distance to the player ship, and I think what we'll do for that is we'll have a separate timer running, maybe just once per second. 1 hertz is fine, whereby we just check distance to the player ship, and if we've passed out of visual range, essentially, we will despawn the object, so it's no longer available to us. Well, to be honest, we don't even need to do that, because if we're managing this based on our grid system, then as soon as the grid containing those objects is no longer valid, so that becomes invalidated. If that cube has a reference to all the things in that cube, then what it can actually do is just loop through all those objects and just ensure that they're destroyed. So if it fires an event to destroy the actor, then it will also itself then destroy its proxy object. So probably in that order, it will destroy the proxy and then it will destroy itself. And obviously if you then return back to that location, like if you turn the ship around, it will just respawn all those objects again. Yeah, I think that should work. So yeah, the next step really is just getting that working. So let's just close down a bunch of this a minute, and we'll take this from the top. Again, we're going to have to debug spam this step by step. Right, so we know that this is going to be accurate. We don't need to wait for data, so that can go. Those three can stay the same. We don't want to run this check if we're in the middle of doing something else. We don't want it to kind of try and generate sectors whilst it's already generating sectors. So we're grabbing our vessel ID, checking our ship coordinates. We might need to do something with this, because obviously this is spawning in objects. Now, I suppose if we fly off in a different direction with a shuttle, then that shuttle is going to be in a different series of local sectors than the main ship. So, that being the case, it does need to spawn its own objects. So we need to make sure that there's no overlap there. So yeah, we're going to have to track which local sectors are actually actively generated at any given moment, because what we don't want to do is double up on objects if the ship and the shuttle are flying alongside one another, because otherwise the system's going to just spawn two of everything. So we're going to do some checking with that. What we might actually do is check which vessels are actually active and where they are, and then spawn in the sectors for each of those vessels at all times. That's probably the best way to do it, because if we've got two vessels that are in the same place, then it will just skip the second one. Because again, we only want one of everything. Yeah, so that would end, the logic there would end up changing. So calculate our sector ID. So we're making everything 1,000 rather than 100. So we just need to increment all of these accordingly. And our unit of measurement is kilometers, not light years. So we need to make sure that we divide the actual location of the actor accordingly by 100,000, I think it was. Okay, so that's them. And same for this one. I'm pretty sure that the sector midpoint and the sector ID are in fact one and the same now, so this is probably a little bit redundant. I will double check and confirm before deleting anything. Okay. Oh. Actually, I can't remember why I was timesing that by 1,000. So, right, of course. So, yes, we get the ID, but then we need to times it by 100 for light years, because each sector is 100 light years. So we need to know how many centimeters are in, sorry, how many kilometers. Yeah, so 1,000, that would be right, yeah. So it's 1,000 kilometers. As long as we're consistent with our unit of measurement, everything should work out fine. Just need to make sure that everything is using kilometers. So hang on. Yeah, so on that, oh, actually, yeah, so that is right. So I need to check that, and make sure we convert that to kilometers. So looking at our length converter, so 1 kilometer is 100,000 centimeters, which means we need to divide that by where are we? Float double there. Yeah, so our local coordinates are in centimeters, so we need to convert that to kilometers, and then all of these are in kilometers. So again, we need to make sure we're consistent with that, otherwise it will mess up. Let's make our server. This is another one of those like meta things. So this is our object gen, and then when we drag that into the world, we'll have our object gen as well. Add it to our server farm over here. Oops. Yeah, I need to look at blueprint function libraries and see how that affects the reference chain, because I'm always worried about building reference chains that end up doing bad things when you cast between objects. But yes, a blueprint function library would be useful for that sort of thing. Okay, so the object gen then in the world will start to track the location of the ship locally and then start to generate local sectors around the ship. So I'm going to stop it. I'm going to stop it there so it doesn't do any of that work. So just so we can do some debugs, because we want to make sure that it's actually generating sectors properly at this point. Let's format that. So what do we have here? So our ship coordinates, which I can't spell. We may as well just drag in those variables. Convert to a string. Right, so that's where the ship is. So we want to know which sector the ship is in. So ship sector midpoint, which should be a round number. Where are we? Ship sector midpoint, and we also want working sector midpoint. So we generate a bunch of offsets and then loop through them. ship sector midpoint, and then working sector midpoint. This is just going to allow us to compare all the different vectors to make sure that they are as they should be. Yeah, so it's going to do that for each of these 30 something. What was it, 27? What's 3 cubed? Is it 3 cubed 27? I think it might be 27. Yeah, so it will spam this 27 times as it goes through each sector. Of course, we do need to update this macro, make sure that we're incrementing our coordinates by 1,000 each time. And again, we're generating a 3 by 3 by 3 grid. If we wanted to generate a bigger grid than that, then we need to calculate more offsets for that grid. And then we'd probably build more of a sphere of sectors at that point. Something this doesn't do, and this is something that I've been meaning to get around to at some point, is when we move, say, left from one sector to another sector, we're regenerating the full cube of 27 sectors, rather than reusing the ones that we've already generated. So really, if we're moving forward by one sector, we should only be generating 9 sectors, because the other ones we've already used. We're only just shifting them forwards one by one unit. So we need to add that as an optimization, because that will greatly reduce the amount of work we're doing as we're moving through galactic sectors. It's much quicker to grab the data than to regenerate the data. Don't want to send anything yet either. So right, let's see how badly that breaks. And we will keep that around because I want to have a bit of a read and see what we're actually generating. Oh, we need to kill the spawner. Forgot we had that. So test spawner can go away. Right, so great. So the midpoints are all whole numbers. That's what we want to see. So that's where we are. That's our local sector middle. Right, and then we'll collapse these to sector IDs just to see what they look like as well. Right, so if we just insert sector IDs into that, just want to make sure that it's actually calculating that properly. So this should be all those numbers effectively divided by 1,000. Okay, so yep, so it looks like it's generating the grid. So we've got 75715 on the X. Yeah. So the ship coordinates and the ship sector midpoint are all spot on. And then the working sector midpoint yeah, is also spot on. So the one I'm looking at is exactly 1,000 difference between two digits. So I would say that is definitely generating sectors. So we now have a working grid around the ship. It would be nice if we could visualize that, wouldn't it? So let's do so. I've been meaning to do this for the galactic sectors as well, but haven't really kind of bothered. So what we need to do, ideally, if we render a cube as wireframe, then we can draw a cube which is sufficiently scaled to represent each sector. So if we do that here, so rather than generate sector, so each one of these, we will add doing it from a vector. So add a static mesh component. I will set that as a simple cube. The default cube should be 1 meter, 100 by 100 by 100. Yeah, so that's a 1 meter cube that we've got. And then what we'll do is we will set world location just to make sure we set that accordingly. So if you make it 1,000 times bigger, then it should be a 1 kilometer cube rather than the 1 meter cube. And then we will set the location as the working sector midpoint. So it should make a grid of said cubes. And then we just need to give that a wireframe render. Yeah, that'll do. Yeah, because I think the other wireframe one is the hollow display, which will disappear. Right, let's just try that a minute. Well, I'm not seeing any cubes. Hang on, let's... of course. So... Right, so this is that whole thing isn't where you expect it to be thing. Because we need to obviously take our object and offset it. So we just grab that a minute. The joys of moving space around the ship. You have to do some offset shenanigans. Right, let's grab that over there. So it doesn't matter where we spawn it initially. We will take our working sector midpoint. We make a transform. So we've got our location. There. So working sector midpoint, so that's in kilometers. Again, we need to make sure we get our units of measurement right. So that's going to be in centimeters. So we need to multiply that by 100,000 to convert it to centimeters. So kilometers to centimeters. Rotation we don't care about. We'll keep the transform scales the same. Right, so that's the new location. So that should align with the ship. Set relative scale. Just make sure that we rescale it at 1,000. Right, let's try that a minute. Still not seeing any cubes. There's a cube. There's another cube. So I think, yeah, I have a grid of cubes. They're just not the size I want them to be. Hang on, let's scale them up a minute. So those cubes should be 1 kilometer. Hold up, what am I doing wrong? So there are 1,000 meters in a kilometer, i.e. a kilometer. So the scale should definitely be 1,000. Have I miscalculated that maybe? No, so that was definitely right. I will, however, check. So 1 kilometer is, yeah, 100,000 centimeters. So 100,000 centimeters. So that's definitely in kilometers. So when we do our sector offsets, so we're taking our vector, timesing it by 1,000. Yeah, because we're offsetting each coordinate by 1,000, because our unit of measurement is kilometers there. While we're here, we'll just make sure that we don't have any collision or anything on that. Oh, hang on though, would I have to cube that? Perhaps I need to cube it. So right now it's 100 centimeters, and if I wanted that to be a kilometer wide, although the scale is 1, so it would have to be 1,000 along each axis. So nah, it's not that. So either they're too far apart or they're too small, and I think it's probably the former. Let's just move the ship. Now I imagine that we're stuck in place because obviously we're spawning them as part of the static environment. And what? Oh, of course. Right. So yeah. So what you're seeing there is as we're moving, obviously we're passing into the next cube. So what it's doing is it's spawning more cubes. So those would be where content is being spawned. And obviously they follow the ship. Given that they're going through Earth, I think they're just too far apart. So let me put this back down to 1,000 a minute. I'm wondering whether the issue here is actually our offset code. Should that in fact not be 1,000? So has that just created a big old pile of cubes on top of each other? Oh no, it's over there. Interesting. Out of interest, let's see where it's actually stuffing all of that, because obviously the ship is not in the middle. Oh, hang on, the soul didn't generate. I guess which is the other awkward thing actually. The ship's not actually in the middle of a 1,000 light year cube, so all them little blue boxes, right? So that's the middle of the cube over there then. Which will take forever to get to. So it would be better, therefore, to put the ship in the middle of a cube. That's the best way of doing that. I guess if we... Yeah. if we get let's find the event graph. It's disappeared. Yeah, so if we spam that again, a minute, we will take a note of what our ship sector midpoint is, and then we'll move the ship to that location temporarily, so that the sector midpoint will be generating on top of us. So if we just snip that a minute, just so that I can remember where it is. And then on here, we'll override that, and then we'll change this. So it's 75715, and that would be times 1,000. And then we have minus 35690 times 1,000. That doesn't seem like enough units to me, but we'll roll with it and see. And then we've got minus 125,357 times 100,000. Hang on. Times 100,000. And then that one was 35690 times 100,000. Pop that there. Right, so that should put the ship right in the middle of the generation region, and then we'll go back to generating those. So they should be generating immediately around the bridge. Or not. So that's placing us right up against Sol, which is not where we want to be. That's interesting though, actually. Why is it reporting such oh, I know what I'm doing. Yes, it's because I'm doing this. So that was the sector ID that I was working with there. Hang on, bear with me. It's late. My brain's getting frazzled. Right, so we'll take that, pop that there, multiply it by 100,000, grab the coordinates. Right, that's looking more like it. The number was too small before. Right, we'll grab a snip of that. Right, let's try that again. So that was 7571500. That's more like it. Nice big number. And then that one was minus 35690000. And then that one was minus 125357000 in kilometers. Multiply by 100,000. That should put us where we need to be. He says with no confidence whatsoever. Ah. Right. Okay. Getting somewhere. So these look like they're overlapping. Right, so we're definitely spawning them, so sector offsets then. See, I'm sure that these should be 1,000, and I'm sure I'm also missing something. Let's just take a look a minute and see how separated they are. Yeah, that can't be right. Okay. So why don't we, whilst we've got SketchUp handy, actually make a mesh that is exactly what we need. So if we just get rid of that. Be gone. Right. Ooh. one sector cube. Okay, so we know that this object is definitely 100 by 100 by 100. See you, Max. Have a good one. Don't know, Anassi. It really depends on the bugs. Like I said earlier, I have a list of bugs on the tracker that need fixing, and it's all down to how quickly I can fix them. So, you know, really, it's like how long's a piece of string? With any luck, yes. But again, it's all down to those bugs. Oh, sorry, Max. I'm at like frazzled brain point now, so don't expect me to make any sense. Sector cube. Hardy har. See that? That's moving far too much to be considered 1,000 kilometers in size. Right, so I'm sure that this should be 1,000 because we are working in 1,000 kilometer scale, and our next cube needs to be 1,000 kilometers over, so that has to be 1,000. It wouldn't make sense otherwise. So it must mean that the scale is off. Let's ditch that. Wait a minute. I think I've just realized what I'm doing wrong. So our cube is 1 meter. So by timesing it by 1,000, it makes it 1 kilometer. But of course, we don't want 1 kilometer, do we? We want 1,000 kilometers. So that should be 1,000,000. Surely. That's too many. No, it's not. It's not enough. Oh, is it adhering to the initial scale? Oh, I think it might be, you know. Okay, that's pretty massive. Where did the other ones go? Unless my scale's off still. So hang on. Let's just check with the length converter. So 1,000 kilometers is 1,000,000 meters. So yeah, that scale should definitely be right. So that is the correct scale. In case there's any doubt, let's just reset the scale after doing the transform. Not that we should need to, but set it anyway. It's definitely 1,000,000. Ah, there we go. Right. Got there eventually. Right, so that is our sector grid. Right, good. Now, we've got a few minutes left, so what we're going to do is for each one of these, we're going to add them to an array. So starting mesh component, let's just grab that a minute. Sector cubes, because this is useful to have as like a debug. And that needs to be an array. Let it do its thing. To see if I can turn this off, because it's annoying every time it does it. Yeah, so before we do any of this, we kind of need to just clear. Actually, we want to. I think we can just destroy. Can we not just destroy from there, or are we going to have to loop it? So for each one of those, we're going to destroy the component, and then we're going to clear the array and continue. So this just means that when we traverse to the next sector, we will delete the ones we've got. Yeah, and get rid. So they're still going to move with the ship, though. And we're just going to add add each of those to our array so that we can destroy them after the fact. Right, so as we fly forwards, not quite sure what it's going to look like, because obviously they're going to be moving with the ship. Yeah, so it's constantly regenerating them on top of each other. Yep, okay, fine. So that being the case, yeah, let's very quickly just make a looping event up here somewhere. Timer by event. Do the thing with the thing. So we're going to get rid. Yeah, actually. So we're doing all of that. So if we just do start regenerating sectors, so we'll just do that maybe like every 0.1 of a second. So they'll be jittery, but they'll be moving. Yeah, so ignore the jitter for a minute. If we start moving the ship, you should see the grid reforming as we progress forwards. Or not. Hold up. So ship local calls, blah 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 blah. So destroy them all. Work out where we are. Spawn them all. Perhaps we're doing it too quickly. Let's maybe do that every half a second. I think it might be deleting them before it's finished making them. Yeah. Okay, that's more like it. Yes, Madman. Oh, no, don't go that quick. Not quick enough. If I right, so I made a delayed for each loop, which basically gives us the ability to just slow down loops if need be. It helps prevent too much of a lag spike when generating the sectors. Which means it's taking longer, obviously, to spawn the sectors, because it can do it no quicker than once per frame. Yeah, that's better. It's not glitching now. Oh, and Earth's not there, just to be annoying. You can use the drone camera. If you go to the first door on the left as you leave the bridge, there are a bunch of drones on the floor, these things. If you hop in one, then you can fly out of the ship like that and then fly around to see it. Mouse wheel speeds it up and slows it down. Ooh. Although don't set it too quickly, otherwise you get very lost. So same again, let's just start the ship moving. Right. That's more like it. So as we pass into the sector boundary, you'll see that it's now generating an additional sector ahead of us. So as that boundary there moves across, we'll hit that and then generate the next grid in front. So this is basically us now just spawning those sectors around the ship, and it should be keeping pace with Earth, because they should be in the same reference frame scale-wise. Let's see if we can speed that up a bit, now that we're not delaying our loop. Risk going a bit quicker. There we go. So as we're going quickly, you can see that it's now like rapidly generating the sectors around the ship. If we slow down again. Maybe go a bit quicker. There you go. And then you can see that as we're going along, we're generating those additional sectors in front of us. And then that then allows us to then start spawning stuff within that space. Now obviously each one of these cubes is 1,000 kilometers across, so we're moving pretty rapidly. To turn off shadow casting, it's blocking the sun. Yeah, well, this So once you're at FTL, we'd be using a much bigger grid. So this is the sublight grid, which is why it's only 1,000 kilometers. So you would never be flying through it this quickly at sublight. It'll be, well, if we're doing 1,000 kilometers a second as our maximum sublight speed, then it's going to take, well, I guess that's about this, isn't it? This is about 1,000 kilometers per second. No, sorry, 1,000 meters per second, not kilometers. Yes, so it's going to take 100 seconds to get through each cube. So you would never be going through them this quickly. When we do the FTL ones, however, obviously they will be much bigger. So we can do the same thing. Now that we have this available as a debug view, we can actually do it for the Galaxy as well. And not only that, but also the holo display. Because I think it would be nice to display the sector boundaries on the holo display as well, just for like information purposes. Just so, you know, you've got some visual indicator of, you know, where the actual galactic sectors start and end. But yeah, so what this series of cubes is achieving for us is we're spawning content. So again, at this scale, you wouldn't be going this quickly. But every time those cubes regenerate, we're now spawning objects into the world that you can go and interact with. So, you know, each one of these could have like a dozen asteroids in it. One of them could contain the remnants of a battle, so there could be like dozens of destroyed ships in the cube as it generates. So as you approach that location, you're then approaching like an old battleground that's, you know, strewn with bits of ship everywhere. But then that would be generated dynamically and only when you're in that region. So the beauty of doing that is that like if you didn't happen to fly there and happen to get within range of that cube, you would never know that that stuff is actually there. So there could be a star system that has some really cool thing in it that no one ever finds because no one actually flew to that specific location within the system. So if you're just flying in, doing a medium range survey, and then just flying off to the next system, you're basically missing all the stuff that could be there that you will find if you slow down, take your time, and actually properly explore around each planet. So we're rewarding players for spending more time actually investigating a star system rather than just scanning and running each time. I mean, most of the time it's going to be, you know, an asteroid, a rock, and, you know, you've seen one asteroid, you've seen them all, you know, they're pretty mundane. But, you know, there will be other stuff too. For the short range, which is what this one is, so this is the sublight grid, and the sublight grid, which just crashed, good timing. The sublight grid will have a view distance of 1,500 kilometers. So that's for, you know, particularly small objects. When we do the slow FTL grid, and we will enable and disable it based on FTL speed. So if you're like rocking through a system at maximum FTL, then we won't even bother drawing the grid in the background and spawning the objects, because you're warping through so quickly that we haven't even got time to spawn them before they be despawned again. So yeah, so at sublight speeds, 1,500 kilometers of view distance ahead to an object, which is pretty far at sublight speeds. Like I said, it's going to take you 100 seconds, probably at least, to traverse one of those 1,000 light year cubes. When we step it up and start generating the medium range cubes, I think, I don't know, probably 100,000 kilometers per cube. at medium range, and this is going to be object scale as well. So obviously the short range grid, the sublight grid, is for small objects. So we're talking like an individual satellite, like the James Webb telescope would be in that grid because it's so small. The medium range grid is going to be much larger objects. So something between a car and a small moon, something as big as the Magellan class, maybe, big things that you can see from much further away. So we'll definitely make that grid much bigger. But the beauty of the system is that now that we're generating that, we can optimize and tweak the scale based on playtesting and how that actually feels. Because the scale is arbitrary. We can make them as big or small as we like. It just is how they work in practice that matters. But yeah, so I think we have achieved much success tonight. So to recap, we have our grid, or we had our grid before it crashed. Oh, of course, the server isn't there, so it's not generating. But yeah, so the grid works. We're spawning dynamic objects, and they in turn spawn their proxies, and all that works. And the nice thing about that is that also works for planets. So that means we can finally have planet collisions once I swap it over to that new system. And yeah, I think we've made some big steps there tonight. So, hurrah! Yes, Mad Dementor. So the medium range, the short range 1,000-kilometer cubes will only be spawned and managed when you're not at FTL. As soon as you go to FTL, that system just turns off and it doesn't spawn anything. Instead, it then moves to the medium range grid, which will then start spawning medium range. Well, it will already be spawning medium range objects. That won't turn off at sublight either. Once your FTL speed gets to the point where you're exceeding the grid size within a certain number of seconds, then we'll shut that grid off as well. So the slower you go, the more grids that will be running for spawning content. The idea here is that we are creating depth within a star system, and by adding layers and layers of spawning grids, we're creating smaller and smaller objects in smaller and smaller ranges. So even in orbit around a single planet, you can be coming across, like I said, artificial satellites and other things. Well, as you've asked, I will give you one last example, because it's particularly cool and I really like it. What's the best way to do this? I guess we'll do it as the server in the shuttle, assuming that Sol loads, which it has. Right, so if we get the server there, oh, hang on a minute. Let's turn off the spawner. So of course, because the engine crashed, I hadn't saved having deleted that. Yes, it will, Mad Dementor. So the sector gen code will be running continuously. As soon as the ship is moving at a speed where things need to be spawned, it will get on with its job and start spawning those things. Just having to undo all the stuff I was doing for testing. So we'll get there. We'll get to the example. And Sol didn't spawn. Bear with me. This is a test map thing. It's like it accesses the database and it thinks the database is valid, but for some reason it then just doesn't recognize that you're in the Sol system. Do it a few times and then it will. But like I said earlier, it works fine when packaged, so I'm not going to cry about it. It is, however, annoying when you're trying to do something. Come on. Give it a minute. Thank you. You know what? I'm just going to fly to a different... No, I can't. Say I fly to a different system, but I can't because the shuttle's not there. Which is the thing that we're demonstrating. The fact that the shuttle and the main ship exist independently of one another. Right, finally, Sol loaded. Right, don't need the client there. Why? What on earth? Don't you just love it when things just randomly, for no reason, mess up? Right, that's the mesh. Right, finally. So the mesh has loaded. Sol has loaded. We're good. Okay. So, so as the server, we are on the shuttle. So let's pop that there. So there we are. Turn the torch on. We're in a shuttle. That shuttle has its own independent view of the galaxy. Separately to that, our client in multiplayer is on the Magellan. The client doesn't have the Sol system because you can't open the SQL database twice. It locks it, so that's fine. Now, as the client, I can press the controls and you'll see that like the stars are rotating for the client because the client's on the Magellan. And for the perspective of the shuttle, the Magellan is moving. So both the shuttle and the Magellan have two completely independent views of the galaxy. So we can control the Magellan completely independently. And the particularly cool thing is, if we go to FTL and let's just move the Magellan forward a bit so you can see the engines and stuff. Obviously that's not the final model of that yet. Needs a lot of exterior detail work. Right, so there's the Magellan, which is independent of the shuttle. So if I engage FTL on the Magellan, cool things happen, and it's gone. Now, right now, the FTL effect does show on the shuttle when it shouldn't do. But from the perspective of the client, if we get out the chair, the client is now flying on the Magellan, and it's off somewhere else in the galaxy. In fact, if I, just for a laugh, if we go to our long range sensors and go there and go to say that, so you can see that the Magellan with the client on it is quite happily flying around the galaxy, and yet our host on the shuttle is still parked outside of Earth. So apart from the fact the FTL effect is showing when it shouldn't do, they're still in a completely different part of the galaxy, independently to the Magellan. That's the static interior up there, which we need to hide. You shouldn't see that normally. That's kind of the smoke and mirrors that we're doing. So basically, you know, the shuttle interior is static, the Magellan interior is static. We're moving space around both. So we'll hide that, and that will just preserve, you know, the illusion of being somewhere else. So back on the Magellan, you will see that we should rock up to another star momentarily. There's a whole bunch of stuff in this system. So there we go. So the client on their copy of the Magellan is now in a completely different star system on a completely different planet to the host, which is still at Earth. Now the really cool thing, and let's hope that this works, is the host simply needs to exit the shuttle, and now they, in a packaged game, will be in the same planet. The problem is the host and client can't access the database. So on the host, obviously you've got all the real world stars that are in the real world stars database. They can't be accessed on the client. So what the client is seeing is a procedural world that the host doesn't know about, because the host is loading real world locations. The only way that both of them would see the same view of the galaxy is if we did something like that, and then did a ship teleport. So we've teleported beyond. Did we teleport beyond? We should have teleported beyond. Oh, I clicked that. Like an E-JIT. Right, so we've teleported. So now both the client and the server are regenerating their galactic space, which is why it is all laggy. So I need to wait for both of them to finish. There we go. Right, now we only have procedural stars. So if we were to go to that one and just go there. Make sure I did actually send that, yeah. Okay, now as the host, if I go back through this portal, I am now back at Earth. Now you saw it had to regenerate all the galactic sectors because this is a completely different region to the galaxy. It's like 10,000 light years away. So you get that lag, obviously, because it's regenerating those sectors. Now, normally, the shuttle and the ship won't be that far apart, but it does mean that we can have two completely independent vessels, both exploring the galaxy separately in completely different directions at the same time. And what you see out of the window of each ship is obviously relevant to where they are in the galaxy. So if I hop back through here again, and of course it then regenerates, and you'll see that then both the clients and the host are coming up on the same planet, on the dark side, of course, because why wouldn't it be? Then the other cool thing is that we can run down to the surface. Obviously this one has an awful terrain, so let's just go to a different one in the same system. You'll do. And it's a gas giant, that's not very helpful. It's managed on the server, so all the grids are only ever loaded once. Cheat our way over a minute. Planet and Earth, and then back through here, and after it's generated the galaxy again, planet. Okay, so yeah, that's working basically. Obviously you won't be jumping like the player across the galaxy like I'm doing here, so that lag while it has to regenerate the galactic space won't be happening normally, but that just shows that it's possible, and that's how we'll be doing things like wormholes. So the fact that I can walk through a portal to Earth from another star system like almost instantly is basically demonstrative of how we're going to be able to do wormholes and other things like that within the game. If I run back down to the surface, does it have one? Hello? Not on that one, apparently. Yeah, so I was going to say, once you're on the surface, the client can join you. The client can't go through first. It causes issues. That's something I need to fix, but yeah, you know, these things all get ironed out. But there we go. Much progress. So on that note, we're half an hour over time, so I shall wish you all adieu. And thank you for bearing with whilst we experiment with new stuff. And oh, let me check the calendar a minute. So So yeah, so Sunday stream is on. Obviously Wednesday stream next week won't be, because it's Christmas Eve. So yes, so I will see everyone on Sunday, and then we'll kind of have a clearer picture of what we're doing over Christmas. So have a good week ahead, and I shall see you on the next one. Bye!